Especially this part. Okay, just tell me one thing. Do you guys have something called as Jalda's method, that method, this method, and all? Heard of it? Or okay, till where do you guys have for this exam?
Hyperconjugation.
Okay, fine then. Cool. Then to those classes I finish it off. Till hyperconjugation, which means you'll have learned something called as inductive effect, electromeric effect, mesomeric
Yes,
effect,
sir.
resonance,
Yes, sir.
all those things.
Positive,
It
negative.
went over the head.
Yes, sir.
Okay, fine. Listen off today for today's class. This exam, for this test, it will be short. So basically, there's something called as isomerism, which everybody knows sitting here because ICSE syllabus, isomerism. Now, in one sentence, if we are trying to define isomerism, very simple. Compounds having the same molecular formula but different structural formula. I like that. Same molecular formula, but and I would suggest you guys not to skip this way of learning just because in 11th standard. Follow the same way. Okay, same molecular formula but different structural formula. Structural formula. Okay, this is the most important thing. Now, obviously, under these things, there are multiple types. One is called as one is called as structural isomerism. The other one is called as stereoisomerism. Nothing, you guys. Nothing is there to mug up right now. Don't get scared also looking at the names because all these things are kind of going over the head at this point of time. I realize this is structural. This will be stereo. Okay. Now, I'll tell you the meaning of both these things. Understand? Structural meaning what you guys learned in 10th standard. Okay. Functional isomerism, where the functional group differs. Position isomerism, where the position of the group differs. Next is chain. All these, whatever the left hand side, the structure thing, is completely learned by you guys in 10th standard itself. Nothing new here. It's just that one step forward will be going. Just one step forward. But this is where your actual skill lies. Something called as stereoisomerism. Now what happens here is, in stereoisomerism, there are again two subparts. One will be called as geometrical isomerism, geo. The other one will be called as optical. Should you mug it up? At this point of time, not required. But let me tell you the meaning of stereo. Stereo in organic chemistry does not mean radio. No. Okay. See, stereo, radio, all these things are the same. I realize that. But end of the day, in organic chemistry, it means space. Okay. Space, just like, let's talk about a ball. You're kicking the football. At some point of time, it's in the air. No. Just imagine, instead of the ball, there is carbon. Now that carbon, how do you locate it? You basically, in the most basic English, if I'll have to define the carbon which is flying in the air, I'll have to tell the carbon is surrounded by space or is somewhere flying in space. That's the best way to tell. It is actually in terms of space. There is nothing else which is going to be different. So that carbon is not going to go alone in space. Along with carbon, it's going to take hydrogen, it's going to take oxygen, it's going to take n number of things. Just like an organic compound, it is just that if we are not going to draw it on paper, it'll be somewhere in space, flying around. That concept where it is flying around in space is called as stereoisomerism. Now, what is the advantage or disadvantage? I'll tell you. Now, to be honest, it's more like a perspective. I actually feel it's an advantage if you are in space because perspective differs. The way you see the carbon and the way other person sees the carbon will not be the same. I'll tell you why. Because let's say the carbon is in front of you, but behind you, there's one more person seeing. The way he sees the bonding happening and the way you guys see the bonding happening will differ. I'll tell you what I mean. For example, let's say carbon is here. How you guys are seeing is like H, H, and H. Fine. There might also be one more H which is somewhere here, one more H which is somewhere here, one more H which is somewhere here. Now, if you ask me how is this possible? One carbon can only have 3 hydrogens, no? But right now, I've drawn 6 hydrogens. This is called as a front view. Guys, this front view, side view, also called as lateral view, top view, all these things will work only in stereoisomerism. This is the front view of it. The side view will actually look like this. 1, 2, 1, 2, 3, 1, 2, 3. Okay, this will be the side view of it. Now, if you ask me, sir, are both the compounds the same? You guys can check. You will tell me, you obviously tell me one difference. Sir, in the first one, only one carbon was seen. In the second one, 2 carbons are seen. That's exactly what I'm trying to tell you. When you're seeing from front view, the other carbon which is behind the first carbon will be invisible because both are coinciding. Okay, both are coinciding. Now, by chance, see, the whole concept of space is rotation is possible. Between whom? Between both the carbons. Fine. Now, just imagine the first drawing is like this. In the same space, the same compound, let's say the first one remained the same, the second one rotated. How does rotation, how should you show rotation? Very simple. You write C here. you draw two H bonds on top and one at the bottom. Fine. So if you see, both are almost the same, but their arrangement in space is different. So both are the same compounds, but arrangement in space is different. You guys can't rotate a carbon on paper. Impossible. But the same carbons in space can be rotated. Once they rotate, however they are seen, if they are coinciding, not coinciding, I don't care. Are they actually seen the same? No. If they are not same, and once the twist has happened, this difference in arrangement in space will be called as stereoisomerism. If you look at this, what we learned initially was same molecular formula but different structure. Correct. Look at this. This and this. Both are same molecular formula but different structure. In this case, rotation was possible because it was in space. Wherever rotation is possible and the carbons have the same molecular formula but different structural formula, that concept will be called as stereoisomerism. That's it. Okay. Now, what is geometrical, what is optical, all these things I'll tell you. But end of the day, it's all about if the carbons are coinciding, it is one name. If the carbons are not coinciding, there's one more name. Similarly, if you see the first diagram here, even the hydrogens are coinciding. Look at the bonds, look at the arrangement. Everything is coinciding. So that will have one more name. If you look at the second one, the hydrogens are not coinciding. It looks like a Benz symbol here. Mercedes-Benz. Okay, not coinciding. So this will be given a different name. The actual names are staggered. All those things are there. Fine, but nothing to worry. Wherever rotation is possible, it is called as stereoisomerism. Any doubt till now? No. Peaceful. Now, we still haven't spoken about geo and optical. I know that for a reason only I ignored that. But this is the basic part of it. The reason I'm actually trying to ignore this part is because after this chapter, there's one more chapter in organic chemistry called as hydrocarbons. That is, see, in first year, there are two organic chemistry chapters. The first one is what we're trying to learn right now. It is called as general principles and techniques. This is more of how we try to extract compounds, more of a basics, how it is prepared in the labs, how it is useful in the factories, all these things. Next chapter is out and out organic chemistry. How is that reaction working? What is the mechanism? So since you guys do not have that right now, I'll give you an intro which I gave you right now, and we'll ignore that. Fine. Now let's talk about whatever you guys have for your exam, which is obviously the next topic. There's something called as fission happening there. Guys, understand, fission or fusion is not only a physics concept. It's both chemistry as well as physics. I'll tell you the meaning of fission or fusion in terms of chemistry. In our language, fission is like breaking up. Okay, fusion is trying to combine together. Now, combine together, breaking up, whatever your perspective is different. I'm talking about chemistry perspective. Let's say the bond breaks between A and B. This breaking of the bond will lead to splitting of the electrons. Now, I'll write the same thing in terms of electrons. I'll write A, one bond meaning two electrons. I'll write B. So once I break the bond, the bond broke, which means electrons are free. If electrons are free, they want to go and settle on one side. Guys, continue. From yesterday, these people are damn annoying, man. Okay, anyways. The bond splits. Fine. The electron has to go and sit. One will go settle on A. One more will go settle on B. Okay. This is the meaning of fission. How does it look like later? A with one dot plus B with one dot. A has one electron. B has one electron. A has one electron. B has one electron. These are also called as free radicals. Free radicals. Now, what does it actually means? There's 1 minute. Hello? Sorry, guys. Let's continue. Free radicals is what you're talking about. Now, this is the meaning of fission. The opposite will obviously be called as fusion. How? And one more thing. Okay, there's something called as homolytic fission, heterolytic fission. What I do right now is heterolytic. Hetero meaning it's a biology, man. A and B are not the same species. No, that's why hetero. Homo. Nowadays, it's full controversial what this is. Anyways, homo means A and A. See. Influence, no, right? B only. A and A. The bond breaks here. Once the bond breaks, electron differs. Like this, it becomes one here, one here. We end up getting two of the same things. In such a dark joke is becoming. Viraj, are you laughing there? What? If you break a bond, what will happen? Get two electrons. One bond is how many electrons? Right, fellow? And once I break it, each A and B will get one electron each.
Yeah.
This is called distribution. That's all. Correct?
But then why will a bond break if they're already bonded?
No. Very good question. I realize you will nothing you study in 10th standard chemistry. NaCl. One, I'll tell you why. I'll give your example. I'll give chemistry example.
Sir.
We'll ask Niyar. Niyar, what example is better, Niyar? If you whatever you tell Ra.
Sir, that
What example will give? Will chemistry only will give or is chemistry will give? He's asking why will a bond break?
Sir, I am laughing.
No, like Dhiraj, what question? Why will a bond break?
Sir, like
It's like asking a friend, bro, why
if they're already stable.
if you are already in a relationship, why will you break up? Some external factor would have hit. That's why. Same concept here also. For example, guys, let's go back to 8th standard chemistry for the next 5 minutes. Sorry for this.
8th grade. That's why I don't remember. I had all.
No. But 8th grade, you learned this chemistry. 10th grade, you did some other chemistry. That you'll remember.
That's that.
Now listen. Hey, Dhiraj, when you break down NaCl, it forms Na plus and Cl minus. Correct?
Yeah.
Water, if you break, what will happen?
H and OH.
Correct?
Yeah.
Now, Na is positive. Anything which is more positive will always say to go and react with somebody who is?
Negative.
Now, it has two options. Either Cl or OH minus. Whom will it choose?
OH minus.
Why not Cl?
So
Because
more negative.
no, that is not no. How can OH be more negative compared to Cl, man?
I don't know.
Cl is on the right extreme because Cl is a halogen. No, remember chlorine is a halogen.
Yeah.
Halogens are very reactive. They are.
Okay.
So
then why are they breaking? If that
they are breaking because this H plus is there. No, here the silent factor.
Yeah.
H on the periodic table is on the left extreme. Correct.
Yeah. And
Left
right
ex-
extreme.
Oh, what the hell? That is He. That is helium.
Oh yeah.
Oh my gosh. Okay. Hey, some random people, man, they keep calling 125 times.
How do you have a SIM on your iPad? Why?
No, that is if you have the same Apple ID, it'll get merged.
Oh.
Okay. But end of the day, we're talking about what?
Hydrogen.
Hydrogen is on the left extreme, which means it's very positive. That since it's very positive, it will want somebody who's very negative. Correct.
Okay.
There can be nothing else who's more negative than compared to chlorine. Understood? Because that is the most negative element apart from fluorine.
Okay.
Fine. So this H plus will actually try to hit on chlorine. That's the actual word. I'm not trying to.
Okay.
Yes, so I swear to God, I'm not trying to cook up stuff. Seriously.
Okay.
H plus is will try hitting on Cl minus. In which state? When they're bonded itself. Here it was H plus. Here it was Cl. No.
Yeah.
Even though they are in bonded states, H plus will never give up because it is more positive. Wants to become more negative. I mean, has to toxic basically. It wants somebody who's more negative.
Okay.
So it'll try hitting on here only. So because of this influence, the NaCl will break. Okay. Once the NaCl broke, H got succeeded. No. H will elope with Cl and form HCl. This is if you ask H when it is more happy, if it is with oxygen or Cl, it will always tell Cl. Because oxygen is negative, correct? It is not as negative compared to chlorine. Getting it?
Yeah.
So, which means Na and OH minus has no options. Fine. Now, actual story is Na will actually try approaching Cl again because they were again, as you're told, they had a bond formed, no?
Yeah.
And that was a stable salt also. Na plus will still try to will try to ask chlorine, but this time The blockage is there from hydrogen here. Na will not even approach chlorine. Why? H is there, no? Now, if you ask me how will this work, HCl is there.
Na will not approach.
We'll try approaching chlorine.
Is there?
No, yeah, correct. This
Okay.
blockage is here. So, how will chlorine think? Who is more positive, H or Na? H is more positive.
Yeah.
So, obviously, whatever H is telling only is correct to chlorine, not Na. Understood?
To chlorine.
No. What chlorine thinks is, compared to H and Na, who is more positive? H.
Yeah.
So, according to chlorine, H only is more correct compared to Na.
Yeah.
So, it believes whom? H. If it believes H, whom will it form a bond with? H or Na?
Yeah.
That's why it will break up and come up with HCl. Understood?
Yeah.
Now, Na has no choice.
Yeah.
Na understood if it tries to go back to chlorine, it is going to become more toxic in life. Correct? No?
Yeah.
Why? Because you can't break this trust right now. It's too strong.
Okay.
So if it goes back, okay, first of all, it has to break the trust, which is impossible. By chance, it broke the trust and broke the bond. Even if it goes and tries to settle with Cl minus, it's not possible. Why? It'll become more toxic.
Yeah.
Fine. So it'll think of another alternative. And it'll think, okay, right now I am Na, I am positive. To bond with somebody, I have no choice. I'm supposed to always choose a negative person. Correct?
Yeah.
Who's the left out negative person here? OH minus. Now think from OH minus perspective. H left it for no reason.
Yeah.
Correct?
So, but then why did Na just leave Cl?
Na? I didn't hear. Sorry, I'm calling him off.
So, why did Na just leave chlorine?
Na didn't leave. Chlorine left Cl. Chlorine left Na.
So H was hitting on Cl, you told, no?
Correct. So
Na would just
so
leave the Cl like that.
it's the other way around. Chlorine leaves the Na just like that. You know why? Because Na, what's the configuration? It'll be 281.
Yeah.
1 in the outermost shell. Cl is 7 in the outermost shell. Who's more dominant?
Cl.
Correct. So who's the deciding factor of the bond there? Cl or Na?
Cl.
So who decides to break the bond or form the bond?
Chlorine.
Got it?
Hmm.
Yeah. Understood as how it works.
Yeah.
Now when chlorine broke down, it only wanted one. It'll play, bro, I just want one. I like hydrogen more than you. I'll take it.
Okay.
That's how it works. So in this case, Na or OH are never the factors. It is chlorine who decides because H was hitting on it.
Yeah.
Understood? It's chemistry. Basically, I briefed whatever has to be learned in last 3 years. Okay. I swear to God. Understood? No, but this is exactly how I learned.
So,
Because
I understood it pretty well. It's kind of relatable.
100%. But it's just that here there was no hitting. You would have got hit basically.
No, sir.
That's the only thing. ಅರ್ಥ ಆಯ್ತಾ ಹಿಟ್ಟಿಂಗ್ ಬೇರೆ ಕಡೆ ಯಾರು ಇರಲ್ವೋ ಬಟ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ನೌ ಡೇಸ್ ಆಲ್ಸೋ ನೋ ಲೈಕ್ ಎವ್ರಿ ಅದರ್ ರಿಲೇಶನ್ಶಿಪ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಬಾಂಡಿಂಗ್ ಬಟ್ ನೌ ಡೇಸ್ ಕಾಂಪಿಟೇಷನ್ ಇಸ್ ಫ್ರಮ್ ಬಾಯ್ಸ್ ಆಲ್ಸೋ ಟು ಬಾಯ್ಸ್ ಗರ್ಲ್ಸ್ ಆಲ್ಸೋ to girls. I am trying to tell facts here. Don't you believe?
In your area, there'll be.
My area, no. Listen up. I'll tell you. I go to this cult, no?
Yeah.
I go. Last night I went there. I went for dance.
Okay.
Fine. I actually like. I'm not in. The other day I told you, one girl is carrying the bottle. Did I tell you?
No.
One girl will come stand right in front of me. I don't know. She only stands. I swear to God, only stand right in front of me all the times.
Okay,
Fine.
your age,
I don't know. I'm not even spoken to her. I've not even seen her properly. She comes. She carries one bottle. She carries one bottle. White color bottle she carries.
Yeah.
On top of that, you know what is it in?
What?
We stand pride. Sorry. Pride month. Next, we stand proud. And below that, there's a rainbow flag. Okay. And she talks to guys also. She talks to girls also. I literally understand this concept there itself. Fusion and fusion. I swear to God, I'm not even kidding. Homolytic or heterolytic, I don't understand. I'm not trying to tell she's bad or she's good. That's not my thing.
So that's hetero. It'll be hetero, no?
Both. Because she's talking to both. You never know how she is. She talks to both.
I get it now.
Understood. If it is hetero means one boy, one girl, she's talking. Understood.
Yeah.
She talks to girls also the same way. I see. If everything was, if you ask me, sir, why are you judging her? Obviously, I'll have to judge her because she's carrying a bottle which says, we stand proud.
Yeah.
If she had carried one random black color bottle, which made no sense to anybody, nobody would have judged her. Now, is she right or is she wrong? I'm not here to comment upon that. I'm just trying to tell, I learned chemistry there also. Understood? You will never, yesterday also, there was one guy standing next to me, left of me. She told, this is what I was telling. This is what I was telling. She scrimped that. And that choreographer thought one step. And I don't know, both of them were very happy looking at the step. I don't know what's there in the step, actually. See, and later, she turned to the girl on her right side. She told the same thing. Like, bro, this is what I was trying to tell. This is what I was trying to tell. I was like, what's happening? Two different songs, but the same girl, two different people telling the same concept. And I don't know. She's maybe from London also, it seems. I overheard her talking. That's why. Okay. I actually pray God. Actually pray before going to cult that nobody like this comes and talks to me. So I swear to, I don't know how to react. Only.
She didn't talk to you yet.
Yeah, I know, not yet. I keep ignoring her a lot of times.
That. What do you mean?
I stand in the last row.
Yeah.
She stands in the last part,
but
one row.
she
So
stands
listen.
right in front of you.
Yeah, exactly. So once she's like, can we shift? She asked. I was like, no. I was like, no. He's like, are you shy? I was like, yeah. Seriously, she asked. I was like, are you shy? I was like, yeah. She told. I mean, dance, no.
Yeah, you just
That's
told,
all.
yeah.
I told you, I am shy. Yeah. No. Huh? Yeah, go. No, next concept comes about new. I'm not even telling. I swear to God, if you come to my cult, you'll find all these people.
Which branch you go to?
I go to almost all the branches around, but the one which I'm talking about is front of Christ.
There's
Front of Christ.
over there.
I go to group classes, ta. Oh, front of Christ in the sense, you'll have to go down the lane. That Nexa you find, no?
Yeah,
The car
yeah.
showroom on top of Nexa.
Oh, the only
Yeah.
cult I know is that Brigade Decathlon.
Yeah, that also I go. Fine, guys, nucleophiles and electrophiles. Very simple. Look at the starting letters. Nucleophile starts with, okay, how do you represent it using the first two letters? This is the representation. How do you remember this? Nucleophile starts with the letter N. N obviously means negative or positive, negative. So therefore, nucleophiles are always negative in nature. Opposite is electrophiles. Electrophile meaning whatever, okay, electrophile is always positive in nature. Please don't mug this up. Learn the logic. Nucleophile representation is the first two letters. How do you remember it? N, which means negative. On top of Nu, you just write negative. Opposite to that is nothing but electrophile. So you write E with a plus. I'll give you a few examples for nucleophiles as well as electrophiles. Very simple. Chlorine, Cl1 minus, Br1 minus, OH1 minus. All these things are nucleophiles. Electrophiles also very simple. H1 plus, R plus, alkyl group, and NH4 1 plus from 10th standard, ammonium. Okay. All these things are electrophiles. But from now onwards, you got to understand that nucleophiles will always get attracted to electrophiles because chemistry always works on one word called as stability. If you want to become more stable in chemistry, you're supposed to form a bond. To form a bond, you're supposed to have opposite charges. No same charges can form a bond. Okay, so understand. Now we'll obviously ask one more question, sir, but Cl2 is there, no? Cl2 meaning Cl will form a bond with Cl. Correct. This is happening because of the exchange of electrons, sharing of electrons. Fine. Cl1 minus will never go and form a bond with Cl1 minus again. Don't get confused. That is why we're trying to learn multiple types of bond called as electrovalent bond, covalent bond, that bond, this bond, and all those things. So Cl2, the formation of it is when Cl shares an electron with one more chlorine. It's like a brotherhood there. Okay, a fraternity. Here, this is not possible. Cl1 minus will never get attracted to Cl1 minus. It can only get attracted to somebody who is positive. Example, let's say NH4. NH4 1 plus was there. This bond is possible. This bond is not possible because 1 plus 1 minus has to be formed for one kind of bond to be there. Remember this. Nucleophiles will always get attracted to electrophiles. In other language, electrophiles will only crave for nucleophiles, not anything else. Same explanation for that also. If you ask me, sir, how is H2 being formed? Correct. H, single bond H. But here, H plus is not getting attracted to H plus again. This is not happening. Fine. They are again sharing one bond. Sorry, they're again sharing an electron to form the bond there. Remember this. So whenever same atoms are being are used in the formation of bond, it's always sharing of an electron which is happening and never transferring. Please remember, very, very, very important. Now, we talk about effects. The first effect, guys, please focus. Next 10 minutes, I think I'll finish off the thing, 15 minutes. Then we'll end the class. But very important. I'll do 2 today, I'll do 2 tomorrow. Because if I do all 4 today, it'll go over your head. We'll do inductive and electromagnetic today. Inductive effect. I'll tell you as to how I learned this. Inductive effect. For this, I'll tell you a small story. I'm not going to try to explain anything. Explanation, your teacher might only have done it. What is important, I'll tell you, how a question will be framed, I'll tell you. They'll give you a set of compounds. They'll be like, arrange them in their increasing order of their inductive effect. This is one of the ways. I'll read the definition for you once. Let's see what you guys understand there. It says the permanent polarity produced in the carbon chain due to partial displacement of the sigma bond, sigma bond pair of electrons towards the more electronegative group or atom. I'm pretty sure none of you guys would have understood anything. It's completely fine. I'll write it in my own language. Permanent polarity, which means this has to deal with positive or negative charges. Remember that. And in this case, it's always a permanent effect. You can't rechange it. Okay? Permanent effect, very important. This will be a question. Produced in the what chain? Can happen only if carbon is present here, because it is organic chemistry. No, without carbon, there is no organic chemistry. Without the carbon, inductive effect cannot be applied on anything else. Now, how will this take place? A partial displacement of sigma bond electrons will move towards the more electronegative group. I'll tell you what I mean here. Very simple it is. Let's take an example. CH3Cl. Okay. CH3 meaning methyl group. I'll write it as R because any alkyl group is represented by R. And one Cl is there. Now they're trying to tell the bond is going to break here. Once the bond breaks, the negative part, which means, okay, what we expected is once the bond breaks, Cl becomes more negative, R becomes more positive. How is it happening is the meaning of inductive effect. It is nothing but when R has a bond with Cl, it will be electrons. Electrons will look like this. It is just that electrons will tend to move towards Cl. Getting it? And wherever electron moves, electron is always a negative charge atom. Okay, negative charge particle. And when more and more of electrons are trying to move towards chlorine, chlorine becomes more negative. Fine. Once chlorine became more negative, obviously R is going to become more positive. Again, if you ask me, sir, are electrons literally moving? Yes, they are literally moving. They're literally moving towards the more negative part. Whenever they move, they carry that negativity along with them and make sure that Cl also becomes more negative. And to obviously compensate that, R has to become more positive. I'll give you one more example with the CSACl. The bond is going to break. Once the bond breaks, more amount of electrons will start flowing or will start moving towards the negative charge and will make chlorine more negative. This symbol is called as delta. It means it is becoming negative. Okay. Then CH3 automatically has no choice but to become slightly positive. Fine. This everybody will understand. That's the meaning of it. There's nothing difficult in trying to remember the effect of it. Unmute and ask me if there's any doubt in the explanation of what I gave you right now. The meaning of it. I still haven't explained the examples. Meaning. Whatever. I won't tell splitting of the bond. I will tell moving of electrons towards the more negative. Correct. That's all. That is happening in the previous thing. Just imagine step 1, step 2. Step 1, bond broke. Once the bond broke, there are 2 electrons which are free right now. Yeah. Both electrons free, which are free right now, they will think something, to which side should they move? Yeah. And they'll decide they'll move towards the more electronegative side. Yeah. In this case, it is more chlorine. Correct? Getting it? So step 2 is what I will explain. Step 1 I won't explain because step 1 is this concept called as fission. Getting it? Yeah. It broke in fission. Step 1 done here. Step 2, it is confused right now. Whom should you go towards is. If it is going towards the more electronegative part, then that effect will be called as inductive effect. That's all.
Oh, that will be called negative inductive, something like that.
But if the electrons are moving towards the more electronegative atom, that concept is called as inductive effect. That's all. Yeah. Fine. Now, guys, how to remember the how to remember the examples? Very important. Order is very, very, very important. Fine. They will be like in the following order, which one exerts the most amount of I effect, plus I effect, minus I effect. Anyways, before that order, as Dheeraj told, we'll finish that concept off. There's something called as minus I effect. There's something called as plus I effect. Negative inductive effect and positive inductive effect. I'll tell you what it means. More than, think for a second. Let's say, if the atom or the group attached to the chain is more electronegative. Okay. If it is more electronegative, then in that concept, it is called as minus I effect. I know you guys would have understood. The opposite will be called as plus I effect. I'll give you 2 examples, then I'll give you the thing as to how to remember it. Fine. Just imagine I took carbon. Right now, to this carbon, you attach chlorine. Fine. Now, if you see, the electronegativity difference between carbon and chlorine is too much. If you ask me how, if you ask me why or how, the answer is the periodic table. Because carbon is somewhere in the middle. Chlorine is always towards your right extreme, which means there is so much of difference there. Since there is so much amount of prominent difference between both of them, the electrons are not at all confused. They know which side to travel. In this case, they will travel towards the more negative side, which is the chlorine side. And once this happens, to compensate that chlorine's negativity, carbon is going to become more positive. Getting it? Carbon has to become more positive. So this, if more clarity is more here. Clarity is better here. Fine. That is why it is called as negative inductive effect. Now, if you ask me, sir, if clarity is more, it has to be positive. No, that's not how it works. Clarity was more in order to move towards the more electronegative side. Getting it? Clarity is more correct. It's a positive thing, but it is moving towards whom? It is moving towards more electronegative side with absolutely zero confusions. That is why it is called as minus I effect. But if clarity is less, I'll give an example. Let's say C is attached to one more alkyl group, CH3. Fine, if you focus properly, in the previous example, what I gave you was CH3Cl. I gave you this example wantedly itself. Let's say the bond broke here. Here, more negative, who is there? Chlorine is there. It will go towards chlorine, which means carbon becomes more positive, chlorine becomes more negative. By chance, this alkyl group only is attached to one more carbon. Now here, once the bond breaks, there'll be a slight confusion here. The electron will think, hey, both are anyways carbon. Okay, both are anyways carbon. Now, if I go to the left-hand side, I don't know what's the advantage. If I go to the right-hand side, I don't know what's the disadvantage. Here, electrons have less clarity. Electrons have less clarity. So, which means there'll be a small confusion before them actually moving. Now, if you ask me, sir, where are they moving towards? They'll move towards the extreme itself. Okay, because the center carbon has to become positive. But when they moved out with a lot of confusion. Did they move? Yes, they moved. But they moved in with a lot of confusion. Now, this confusion will not create proper negative charge, proper positive charge, it won't create. Okay, because more confusion is there. Fine. So what they'll do here, they'll be like, see, I'm confused a lot. The electron will tell, I'm confused a lot. So what I'll do here is, let's not break and form charges. Let's form free radicals here. So once I break, I will go and sit on one carbon as one free radical. I'll come and sit on one free radical. Don't you think the whole I effect only got altered here? Only because the clarity was less. So since the clarity is less here, therefore it will be called as plus I effect. If the clarity is more, it knows who is more negative. Therefore, it goes towards that part and therefore it's called as minus I effect. But when the clarity is less, it is fully confused. Therefore, they'll be like, let's not, I'm not going to move towards the negative at all. I'll split myself, but in terms of electrons, I'll distribute them equally. One towards one carbon, one more towards one more carbon. Bond also broke, even I'm satisfied, everybody is satisfied. Which means clarity was less here. Wherever clarity is left, that is called as positive I effect. That's all. Okay. Now, how to remember the examples? Anything with CH3, fine. See, for example, if one carbon is attached to one CH3, it is called as primary. If one carbon is attached to 2, it is called as secondary. If one carbon is attached to 3, it is called as tertiary. Remember this. So, all CH3s itself. More the number of CH3s, more the amount of confusion. More the amount of confusion, less clarity. Less clarity meaning the splitting won't happen properly. Okay, remember this. So, the best examples for plus I effect will always be CH3, C2H5. All are what? All are the ethyl group, that group, this group. All are alkyl groups. Okay, remember that. Okay, in alkyl group, tertiary first, then secondary, then primary, and then the methyl group. If you ask me why, I told you no. Tertiary meaning more amount of CH3 is there on the carbon. More confusion. More confusion meaning less clarity. Less clarity meaning, again, okay, let's talk about confusion. More confusion meaning you do not know where to go. Do not know where to go is what is plus I effect. No, therefore it is very strong here. More confusion to 3 here. Fine. But in terms of minus I effect, you should not talk about confusion. You should talk about clarity. Who has more clarity? The ones which are negative in nature. How do you remember the order? I'll tell you as to how I used to remember. Okay. Once, obviously, if you're in college, all boys trip, first plan everybody does is to Goa, which never happens. Okay. Now, the same thing was happening in my college when I was in college. That actually helped me remember minus I effect. First year, everybody were in college. Obviously, I think 2 months down the lane, I think after our first test, just like you, we had planned for some random Goa event, which will never happen. It didn't happen. In this process, we started browsing more about Goa. Okay, how many trains are going, how many flights are going, how to go, and all those things. When we had planned, there was a protest going on in Goa by all these so-called activists, because in Goa, as you guys know, a lot of rave parties will happen. Rave parties obviously means a lot of drugs and all will happen there. Fine. One of the women holding a placard said one thing there. There was a statement which said, "We are from Goa. We are the original people of Goa." That was one placard. One more placard said, "Say no to acid and drugs." I'll tell you what acid and drugs means. Acid, okay, fine, not acid, my bad. It said, "Say no to cyanide and drugs." Cyanide and acid, maybe. Yeah, I forgot actually. It says, one woman holding the placard. I still remember the picture. It said, "Say no to cyanide and acid." Okay. It meant cyanide, meaning everybody knows. That's one poisonous thing which people have that in their necklaces, because terrorist people basically. Fine. Next is acid. Acid meaning, I'm pretty sure everybody knows, sitting here knows about those drugs called LSD. Acid is also a drug basically. Okay. Which if you have any plans of going to Goa, you'll know all these things are happening. Cyanide and drugs are very common here. That is what helped me remember the order. Again, I'll write what the placard told. The placard told simple: say no to cyanide and acid. Convert this into chemistry. Ignore the word say. No to is no to. Okay. Cyanide is CN. Acid is carboxylic acid. COOH. This is the order. Okay, followed by your your halogens: fluorine, chlorine, bromine, iodine. This you'll remember because you've been learning about halogens from a long time. So this is the order. Here for plus I it was 3 to 1. This was simple, very simple, 3 to 1. Here everybody trips over the answers here. That's how it's simple. How do you remember the Goa placard? Say no to cyanide and acid. The woman said. I use that. So no 2 is NO2, cyanide is CN, acid is COOH. Then the remaining 4, you guys will remember. Fluorine, bromine, iodine. That's all.
So,
Any,
who will they ask questions from them?
right in which has the highest minus I effect? The answer is NO2.
Okay.
Okay.
No,
Which has
the
the
numbers there? What are those numbers you gave?
what numbers? Oh, here.
Yeah.
Hey, one carbon, if it is attached to one alkyl group, you know this alkyl, no?
Yeah.
How many alkyl groups does the C have? 1. Correct?
Yeah.
So it will be called as primary.
Okay.
If the same carbon has 2, it will be called as secondary.
Okay.
If the same carbon has 3, it will have tertiary.
Okay.
Now, if the bond breaks here, don't you think more confusion is happening here?
Yeah.
More confusion meaning less clarity.
Less clear.
Less clarity meaning plus I effect is more.
Yeah, got it.
Therefore, 3, 2, 1.
And next to the primary one, it's only CH3. Can only alkyl group exist? Like only CH3?
Yeah, only CH3 can exist because this might attach to Cl, let's say. Getting it?
Okay.
In that case. Understood, no?
Yeah.
You'll not forget this, no? Say no to cyanide and acid.
No, sir.
Yeah, remember that. Goa. You guys are not planning to Goa?
Not yet, sir.
Yeah. First friends ಮಾಡ್ಕೊಳ್ಳ ಲೇ.
Sir, it's fun now, sir.
Fun,
Yeah.
Okay, next. Anyways, any doubt in the inductive effect part? No, right? Cool. One more we'll do. With that 4 actually, but if I do all 4, it will go over the head. Next is next effect is called as electromeric effect. It's very simple. Electromeric. There is a reason I put the hyphen there. That is not there in the question. It's just that I put it for me to explain properly. Now understand. Electromeric, the word says electro. I just now thought your concept called as electrophile. If nucleophile is negative, electrophile is positive. So this is nothing but attack of an electrophile. I'll tell you what it means. Let's talk about a double bond. C double bond C, 1, 2, 3, 4. This will be the compound. To this compound, I'll attack with an electrophile. Electrophile does not go only with E, it goes with E plus. Okay, it goes with E plus. That's how it works. Now think for a second. Here, distribution is very important. I'll tell you how I'll remember anyways. One second, guys. I think I'll use a different color for this plus here. You should not get confused. Fine. Now focus. Right now, E plus has to attack the main compound. E plus has no idea. So, understand, if any sort of attack is happening here, first thing which will break is the double bond. The double bond will break. It will become like this. Now, wherever carbon goes, 4 bonds can follow. 1, 2, 3, 4. 1, 2, 3, 4. Now check. Everything is satisfied. Now you ask me, sir, these two are already there. These two are already there. Okay. How did these two extra bonds come and sit here? Listen up. One, the E plus will break up in such a way that E plus will have a corner with them. It will be like, see bro, we are trying to attack one electrophile. Sorry, attack one compound. That compound has 2 carbons. If both of us go to the same carbon, then we'll get defeated. So what we'll do, we will split up. We will split up as E and plus. So E will tell, I will go to carbon number 1. The plus will tell, since you went to carbon number 1, I will go to carbon number 2. Okay. So E plus will have an agreement between them. They'll be like, you go to carbon number 1, I'll go to carbon number 2. Once they break, E will come and sit on carbon number 1. The plus will go and sit on carbon number 2. This is the meaning of electromagnetic effect. Okay. And this is more of a plus E effect. Fine. Any doubt here? E plus will talk. So how we should think here is E plus is not one thing together. It is 2 different things. Now you ask me, sir, what about the bond here? The bond will obviously disappear because if something is plus, this carbon is trying to call out for somebody to come and get attracted there. Okay. So even if you don't draw the one, it's completely fine. That's the meaning of electromagnetic effect. To be more precise, plus E effect. Now, obviously, what is the opposite? Minus E effect. Very simple. Here we spoke about the electrophile. Minus E effect meaning nucleophile. Nucleophile meaning it starts with the letter N. We'll talk with the negative part. That's all. Okay. Now, what does it say? Very simple. Take the same concept. Guys, the main difference between plus E and minus E is plus C you attack with an electrophile. Minus E you attack with a nucleophile. That's all. Same compound. 2 carbons are there. Same logic also. Same ideology, sorry. Plus Nu1 minus. Now, how will nucleophile think? Okay, there are 2 carbons which are supposed to attack. If both of us go to the same carbon, we'll get defeated. So how do we manage that? Nucleophile will tell, okay, we both will split up. Nu will go to carbon number 1. Since Nu is going to carbon number 1, the minus will go to carbon number 2. And how will it look like? Okay, once the attack happens, first thing what breaks? The double bond breaks. Once the double bond breaks, it look like this. 1, 2, 3, 4 was already there. One extra, and later this bond is going to go off because one negative will come and sit there anyways. So nucleophile will go and sit on carbon number 1. The negative will come and sit on the carbon number 2. That's all. Now, this specific negative thing, we'll try to ask for help from somebody else and then try to attract. Maybe the one H plus, somebody was more positive. This is exactly how it works. So, the main difference between inductive and electromagnetic here is, electromagnetic, you know some external factor is required like this. Either an electrophile or a nucleophile. Now, if it is an electrophile, then it will be plus E effect. Remember that. If it is a nucleophile, it is always a minus E effect. But both of them follow the same ideology. What is the ideology? They'll be attacking a compound who has 2 carbons. Okay. Now, if both of them go and sit on the same carbon, they will get defeated. How do they distribute themselves? The plus comes off, the E comes off. The E comes and sits on the first carbon. The plus goes and sits on the second carbon. Same way, the nucleophile splits up. Nu one side, or minus one side. Nu will go and sit on the first carbon. Minus will go and sit on the second carbon. That's exactly how it works. Any doubt on this effect? No? Cool. Out of 4, 2 done. Tomorrow we'll do hyperconjugation and resonance. Whatever is there up to your syllabus, we'll get over. Okay. Then tomorrow I'll do something important also. I won't tell you what. Something with respect to. Okay. I won't tell you which subject also. Make sure you guys attend tomorrow. The moment I send you, I'll finish this off in the first 25 minutes, and then we'll do that important. Okay. And tomorrow, 1 second, guys. The earphone came off. And tomorrow I'll also start teaching you as to how to start predicting the most important questions for your exam. I can't finish everything in one class only. I'll start teaching. Maybe like daily 5 to 6 minutes will spend on that as to how to gather the papers, what MCQs to study, what to skip, all those things. And we'll also start with the CET part, solving part tomorrow also. Fine? No doubt in both the effects. Again, there are 2 more.
How will they ask questions here?
Same. Explain plus C effect, explain minus C effect. They'll ask you to draw like this.
This exactly we have to draw.
Exactly, yeah.
How
I mean,
will you explain?
You oh no, very simple. Electrophile attacks a compound where the E goes and sits on one part and the plus goes and sits on the other part, and it looks like that. That's all. Comment on it. That's all. Don't explain on it. Same thing. If it is electrophile, then it will be called as plus E effect. If it is a nucleophile, it will be called as minus E effect. That's all. That's all. Let me share. Plus, I forgot to circle that plus or minus. You should circle that. That's it. But that,
Diagram should be exactly the same.
what is difficult in this?
So I'm asking.
Yeah. In the sense, how else can you explain this? If you can draw it much more simpler, you can do it, but I don't think so you can draw it. Yeah. Okay. Fine. I'll send the thing on the group, guys. Check that. Okay. See you.
Sir.
I asked that fellow. Okay.
Yeah.
He told there is some link which not only covers for POC but for little actual Python. Understood?
Yeah.
ಅದು ನಾನು ಕಳಿಸ್ತಾನಂತೆ ಇವತ್ತು ಸಾಯಂಕಾಲ ನಾನು ಕಳಿಸ್ತೀನಿ ನಿಮಗೆ. I met him today only.
Like what link, sir?
YouTube link.
Oh, okay.
Okay, there's one channel only for Python, it seems. But you won't learn only what was required for POC. You learn it better also. Understood?
Sir, Faizan yesterday he suggested
Same.
one.
Okay, then see that also.
Okay, sir.
ಅದು ನೋಡಿ ನಾನು ಇದು ಕಳಿಸ್ತೀನಿ. Whatever you feel better, because end of the day you're trying to learn. No, that's why.
No. So no, like the link which he'll send, is that the like the PUC stuff?
And includes that also.
Includes that also.
Yeah, includes that also. Okay. Fine.
Okay, sir.
So. Chat need you are.
Fucker, you called her?